This is for Algebra 2-4, and it's the rational expression test review. I'm just going to go through, I'm going to do all the problems. I'm going to start with the first page, and the second page is on another video. So if you're looking at problems 10 and on, you need to be on the next video. Okay, to graph a rational expression, you need vertical asymptotes and horizontal. The vertical come from the denominator. And we always look at the denominator and we don't want it to be a 0. So we say x minus 2 cannot be 0. We solve that. X cannot be 2. That is our vertical asymptote. So we go to where x is 2 and we draw a vertical line and it should be dashed. Our horizontal asymptote, we're going to look at the degree. So it's not about the denominator, it's about the degree. The degree on top is 1, on bottom is 1 as well. When you do this, you take the ratio of the coefficients, so negative 1 over 1. So y equals negative 1. We go to where y is negative 1, and we put our horizontal asymptote. So there's the two asymptotes, and then we look for test points. When you do test points, you pick x values, and you don't want to just pick any of them. You want to look at your vertical asymptote and pick one to the left, one to the right. So my vertical asymptote was at 2, so I picked a 1 and a 3. Then you take this number and you plug it into the original equation. So when you plug in a 1, you get negative 1 over negative 1. So it's the point 1, 1. We're going to do that. Then you do the same thing with the 3. Oh, that is not the point 1, 1, sorry. 1, 1 on the coordinate plane. Do the same thing with the 3 and you plug the 3 in. And you get negative 3 over 1. When you put it here, negative 3 over 1. So it's 3, negative 3. So that points here. Then your curves get closer and closer to the asymptotes without touching. So closer and closer without touching. You're going to do the same exact thing for number 2. Vertical asymptote comes from the denominator. The denominator cannot be a negative 1. Horizontal asymptote comes from the degree. Once again, the degree is equal, so we do the coefficients, so 3 over 1, so y is 3. We pick test points, and you want your test points to come from the vertical asymptote. So it's at negative 1 right now, so let's pick negative 2 and 0. We plug the negative 2 in, and we're going to get a 6, because we end up with negative 6 over negative 1, which is a positive 6. So we have negative 2, 6. Falls off the graph a little, that's okay. When we plug a 0 in, we get 0. 0 divided by anything is 0. Then we get closer and closer without touching those asymptotes. Okay, and we'll keep going to number 3 here. Number 3 is just saying simplify. So I only have one fraction. It's not like number 4 where I have 2 fractions and I'm multiplying. It's not like number 6 where I'm dividing 2 fractions. I have one fraction. So we're going to factor. Well, multiplies to be 10, that adds to be 7, 5 and 2, and they're both negative. Well, multiplies to be 10, subtracts to be a 3, 5 and 2. Now, that's the difference there between the plus 10 and the minus 10. Here, they're subtracting, so they're going to have different signs. You want it to be a negative 5, because the bigger number is negative. This one's positive. Then you look, these cancel. Here's your final answer. Should take the time to rewrite it, just like that. Number 4. You have to go through and factor everything. When you multiply, that's a multiply sign, first thing you do is factor, second thing you do is cancel. So the top, that first numerator, is already factored for you. Don't distribute. The denominator factors to c minus 5, c plus 5. The second numerator is c plus 5, c minus 5, or minus 1, excuse me, c minus 1. When you multiply, it gives you a negative 5. When you combine them, you get a positive 4c. The denominator, c minus 3, c minus 1. That multiplies to be a positive 3, but when you combine them, you get the negative 4. Then we cancel. C plus 5, exactly the same, they cancel. C minus 1 is the same. C minus 3 is the same. Remember, it cancels if one's in the numerator and one's in the denominator. And we have c minus 5. Same exact thing here. X plus 6, x plus 3, that multiplies to be 18, adds to be a 9. X plus 3, x minus 2, multiplies to be a negative 6, adds to be a positive 1x. The second part is already factors. It's already binomials. Just put some parentheses if you need to. These cancel, these cancel. X plus 6 over x plus 3. Keep going. Division's a little different. When we do division, we want to multiply by the reciprocal. So the first equation stays the same. Excuse me, first fraction stays the same, not equation. Fraction stays the same, and I'm going to multiply by, and we want to flip this. Now, x squared minus 4 factors. And the y's on the bottom now. X plus 2's cancel. You have a y on the bottom and a y squared up top. So that actually cancels, and you have one y left on the top with that x minus 2. You can go and distribute that if you want, but you don't have to. Number 7. GCF. Take it out. You really would prefer to always have a, or the coefficient that's in front of x squared. You want that to be a 1. So I took the 3 out. Once I do that, it factors again. So you want to factor until everything is factored. Okay, you don't want to stop. Should be a minus 3 there. So that multiplies to be a positive 6, combines to be a negative 5x. Denominator. You're going to multiply by the reciprocal here, so we need to factor and flip at the same time. So I just factored this x squared plus 4x plus 4. Now I'm going to factor the top. And then we cancel. So x minus 2, x plus 2, x minus 3. And we end up with 3, x plus 2. And an x plus 1 on the bottom. Okay, number 8. Here we got to do a couple things. First thing we got to do is get up here common denominator so we can add these together. So I'm going to rewrite this problem. So I have some more room to work. We need common denominators first before we can combine those. So on the right, I need to multiply by x minus 3. And here on the left, I need an x plus 3. So that's 4x plus 12. I'm going to go ahead and FOIL the bottom. It just makes a little more sense. And then this is 2x minus 6. Of that. Those are common denominators, so we're going to add the top. So it's 6x plus 6 over x squared minus 9. Now, this was being divided by 18 x squared minus 9. So what you want to do is multiply by the reciprocal. And we see right away these are the exact same thing. Even if you factored them, it would cancel. and I get 6x plus 6 over 18, you are not done. All three terms here have a 6 in them. So that's x plus 1 over 3. You can also see that if you would pull out a 6 on the top, and then 6 over 18 is a 1/3. So you have x plus 1 on the top and a 3 on the bottom. And this is your final answer. Okay, last problem on the first page. Division is done first in the order of operations. So these are actually two separate division problems, and we're going to subtract after we divide. So we have t over 4 divided by t over 5. So that's t over 4 times 5 over t, which is a 5/4 because those t's cancel out. The second division, we're going to do the exact same thing. We're going to multiply by the reciprocal, but this time the t's don't all cancel. T squared and a t leave you with a t on the top and then nothing on the bottom but that 2. So what did I just accomplish? Well, now this reduces to 5/4 minus 3t over 2. It's not considered simplified because we still have a subtraction. We want to combine these. In order to combine, you need common denominators. So I'm going to multiply the second fraction by 2 over 2. That gives me 5/4 minus 6t over 4. Common denominators. So I'm going to, on the top, do 5 minus 6t all over 4. And that's the front page of the test review.